Welcome to Infections 101, a concise guide to how infections work, how they spread, and how we fight them. Over the next slides, we'll unpack the basics: what infections are, the main types of pathogens, how transmission occurs, and practical steps for prevention and control, so you can make smarter, safer choices for yourself and your community. Before we try to stop infections, we need to understand them. This chapter introduction sets the scene. We'll explore the biological causes of infection and the factors that determine whether a microbe becomes a harmless passenger or a dangerous disease. Think of this as the foundation for everything that follows. An infection happens when harmful microorganisms invade and multiply in the body, triggering responses like fever, inflammation, and general illness. When those signs become clear, it's called an infectious disease, and severity depends on both the pathogen and the host's defenses. This slide shows an anatomical view to help visualize where microbes can take hold. Pathogens come in several main types: bacteria, tiny single-celled organisms; viruses, which hijack living cells to reproduce; fungi, which grow on or in hosts; and parasites or protozoa, organisms that live off other creatures. The images here highlight typical examples and remind us that each group spreads and responds to treatment differently. Every infection follows a chain: an agent, a reservoir where it lives, a means of exit, a mode of transmission, a portal of entry, and a susceptible host. Breaking any one of these links can halt spread. This framework helps us target interventions like hygiene, disinfection, vaccination, and isolation. The visual shows the chain of infection as interconnected circles, emphasizing that interrupting even one link stops transmission. Picture the agent at the center, reservoirs around it, and transmission paths linking to new hosts. It's a chain we can deliberately weaken by focusing on reservoirs, exits, and transmission routes. Now we shift to how infections spread in real life. Understanding transmission routes: contact, droplet, airborne, ingestion, vectors, and vertical transfer is crucial because each route requires different prevention measures, from hand washing to ventilation and vector control. Contact transmission includes direct person-to-person transfer and indirect spread via contaminated surfaces or fomites. The handshake image reminds us how easily microbes move between people, while the call-out boxes highlight why hand hygiene and surface cleaning are central to stopping infections in everyday settings. This slide contrasts airborne and droplet spread. Airborne particles under 5 microns can linger and travel long distances, requiring ventilation and filtration, while larger respiratory droplets travel short distances and settle quickly, making masks and distancing effective. The image of expelled droplets visually reinforces how these particles behave. Some infections enter through ingestion, typically via contaminated food or water, while vectors like mosquitoes carry pathogens between hosts without being sick themselves. The slide stresses food safety and sanitation to prevent organisms such as salmonella, and vector control measures to reduce diseases like malaria. Vertical transmission means passing an infection from mother to child during pregnancy, childbirth, or breastfeeding, with HIV as a notable example where therapy reduces risk. Horizontal transmission covers all other routes between individuals. Understanding the difference helps guide prevention strategies for both newborns and the wider community. The immune system is our multi-layered defense network, capable of recognizing and eliminating a wide range of pathogens. This slide frames the immune system as both a rapid frontline and a learning system that adapts over time and prepares us to look more closely at the cells and molecules involved. Key immune players include phagocytes, which engulf and destroy invaders; antibodies, produced by B cells that specifically recognize and neutralize pathogens; and antitoxins, proteins that counteract harmful bacterial toxins. Together, they form complementary lines of defense that explain why some infections are cleared quickly, while others persist. Our first line of defense is physical and chemical barriers: intact skin, mucous membranes in the nose and throat, and stomach acid that destroys many ingested microbes. The close-up skin image reminds us how a simple cut can raise infection risk and why protecting these barriers matters. Vaccines train the immune system by exposing it to harmless fragments or weakened forms of pathogens, prompting antibody production and immune memory without causing disease. This prepares the body for faster, stronger responses on future exposure and, at population scale, contributes to herd immunity that protects the vulnerable. Infectious diseases continue to shape global health. from antibiotic-resistant bacteria to viral pandemics. This chapter sets up concrete examples and their impacts, highlighting how medical advances and public health measures have reduced harm, while new threats and resistance remind us that vigilance and stewardship remain essential. Bacterial examples include MRSA, a hospital-acquired resistant strain that needs strict control measures, and Salmonella, a foodborne pathogen linked to undercooked poultry. The slide also underscores that antibiotic resistance is rising, making careful prescribing and stewardship critical to preserve treatment options. Viral infections present unique challenges. COVID-19 spread rapidly through airborne and droplet transmission and required vaccines and antivirals for control, while HIV is a chronic infection managed with antiretroviral therapy. The takeaway is that antivirals and vaccines are central to viral control, unlike antibiotics for bacteria. Fungal infections like athlete's foot thrive in warm, moist environments and respond to antifungal creams, while parasitic diseases such as malaria are transmitted by mosquitoes and treated with antimalarials. The mosquito image underscores the role of vectors and the importance of prevention measures like bed nets and repellents. Malaria remains endemic in many regions, and the global disease burden slide reminds us that infectious diseases claim hundreds of thousands of lives annually, often among young children in low-resource settings. COVID-19 showed that no country is immune to rapidly emerging threats, underlining the need for resilient health systems. Prevention is always preferable to treatment, and simple, consistent practices at individual and community levels can dramatically reduce infection rates. This chapter introduces the practical measures we'll cover next, from hand washing and respiratory etiquette to PPE and environmental controls. Hand hygiene is the single most effective way to prevent spread. Proper washing with soap and water, especially after toilet use, before eating, and after contact with animals, removes pathogens. Alcohol-based hand gels work against most microbes, but not all, so soap and water remain essential in many situations. Respiratory hygiene means covering your mouth and nose when coughing or sneezing, preferably with a tissue or your elbow, disposing of tissues safely, and avoiding spitting in public. These simple behaviors reduce droplets and contaminated surfaces, cutting indirect transmission risks for everyone around you. Personal protective equipment creates a physical barrier between healthcare workers and infectious material, but only works when selected appropriately and used correctly. Gloves, masks, or respirators, gowns, and eye protection must be donned and doffed with strict technique to avoid self-contamination. Environmental controls reduce reservoirs and transmission, routine cleaning and disinfection of high-touch surfaces, good ventilation to dilute airborne particles, and safe waste management to prevent secondary spread in healthcare settings. Together, these measures lower the chance that pathogens persist and infect others. While medicine has achieved much, ongoing challenges like new pathogens and growing resistance mean the fight is never fully won. This chapter prepares us to discuss the twin problems of antibiotic resistance and the importance of vaccines and global preparedness. Antibiotic resistance grows when drugs are overused or misused, enabling bacteria to evolve defenses that render treatments ineffective. MRSA is a leading example. Antimicrobial stewardship, prescribing only when necessary, completing courses, and investing in new drugs, is essential to preserve the tools we still have. Vaccination programs have transformed public health. The smallpox vaccine pioneered immunology, measles vaccination has prevented millions of deaths, and recent mRNA COVID-19 vaccines showed how fast vaccines can be developed. The timeline highlights successes and why sustained immunization efforts matter. Emerging infections like SARS-CoV-2 show how quickly a novel pathogen can overwhelm unprepared systems. The response requires global cooperation, surveillance, equitable vaccine access, rapid diagnostics, and manufacturing flexibility to save lives when time is critical. In conclusion, knowledge empowers action. Understanding how infections spread and how our immune system responds helps everyone make better decisions for personal and public health. Simple actions, hand hygiene, vaccination, and responsible antibiotic use have outsized impact in protecting communities and breaking the chain of transmission.